All right, so since quite a few people have had questions about this question, I'm gonna go ahead and break this problem down so we can understand it. And so, just based upon the picture alone, we want to pay attention to this shape and understand that it is a proportion. All right, so now this proportion, we have here a situation where we have side angle side. So it's a SIS similarity, and we're going to try to prove it, right? And so what we want to do, we want to be able to set up a ratio, right? We want to set up a ratio based upon this side length and this side, and this side length and this side. So if I just decide to redraw my triangles, right, I have similar angles, which are corresponding angles. I have corresponding side lengths. So this side would then be 40, and this side will be 200. So when I set up my proportion, it would have to be this over this and this over this, right? So I would set up 40 divided by 75, and that's equal to 200 over D. And so now what I want to do with these, I want to be able to solve for D. I don't want to reduce this fraction. I don't want to try to guess. I'm just going to do a simple setup. So the simple setup says that I want to cross multiply, then divide, right? So just going to go ahead and set up this image as it should. So then I have 40D is equal to 15,000. All right, so we've done our cross multiplication of our ratios. So our ratios are always congruent, especially when we're doing with similarity, because the scale factors should be the same. So now what I want to do, I just want to get D by itself. So I'm going to do 40, 1500 divided by 40, and then D is equal to, I got these two zeros, I can cancel them out. So it's 1500 divided by 4, and that's going to be equal to 375, right? So now as I go answer these questions on the screen, I'm going to use that information to answer these questions. So it says the surveyor wants to use similar triangles to determine the distance across a lake as shown at the right. Are the two triangles in the figure similar? Justify the answer. And what is the different distance D across the lake? So are the two triangles similar? Justify your answer. Choose the correct answer below. A, no, the triangles are not similar because the dilation is not considered a similarity transformation. Only rigid motions are similarity transformations. Yes, the two triangles are similar because one of the triangles is a reflection of the other. C, no, the triangles are not similar because similarity transformations preserve angle measure. Since the two triangles have different angle measures, they are not similar. Or yes, the two triangles are similar because there is a transformation composed of rigid motions and dilations that would take one triangle to the other. I'm going to select D because that's what this is. So this triangle was rotated and pretty much a dilation of this triangle, right? So now we want to be able to find the distance across the lake. We found the distance across the lake by taking the ratio. Since it was a dilation and a rotation, or a reflection and a rotation, no, a rotation and dilation, because we rotated this shape because this angle has to line up with this angle. We take this scale factor over this scale factor, and we should be able to find our answer from there. So our answer is 375. So again, we're dealing with proportions with similar shapes. You have to be able to see the proportions, and you have to be able to set up the ratio so that you can find your missing point. All right. You guys got any questions? Let me know.